The site I have chosen is right in the center of the city CBD, has a high demand of electricity use. The selected project precinct is in Sydney CBD between King Street and Market Street, and from Sussex Street to Clarence Street. The buildings in the area are mixed of residential and commercial buildings. The mixed building typology has potential to create a relevantly even electricity usage pattern daily in precinct. The chosen building sites are 183 and 185 Clarence Street, two unoccupied buildings. The 183 Clarence Street building was the old electricity substation building. It was disused from 1958. Energy Australia owns the building and the adjacent vacant commercial building, and these two buildings are earmarked for a future zone substation, according to New South Wales Heritage Branch. From the graphics, we can see different consumers in the area have different energy profiles. For a typical residential user, for example, a young couple without children in the city, the graphic shows that the peak time of energy demands are in the morning from 6 a.m. to 7 a.m. before work, and in the evening from 5 p.m. to 9 p.m. after work and before bed time. During the daytime, from 9 a.m. to 5 p.m., the energy demand is relatively very low. In a typical office building, the daily energy profile shows that the peak period of the energy demands is during the daytime from 9 a.m. to 5 p.m. Main energy use are air conditioning and lighting. The complementary patterns of energy use in commercial buildings and residential buildings show us that there is an opportunity. The local generated energy from residential buildings during the daytime, main source from solar, could be supplied to surrounding commercial buildings, which will make the generation and use of energy more efficient, as save energy into batteries could be expensive. Here is the picture showing the existing electricity substation and the adjacent disused commercial building. Few equipment are required for the site to be a micro smart grid, which include a local power station with a tree generation plant and an on-site waste-to-energy plant, an automated vacuum waste collection system, electricity storage facilities such as batteries and hot water storage unit, electric car charging points, local energy generation such as solar panels for hot water and photovoltaic panels for electricity, small-scale wind turbines and fuel cells. Train generation plant, normally a size of a ship container, will use renewable gas to generate electricity and heat. The heat will be used to supply space heating and hot water use for the area. The heat will also be collected and go through an absorption chiller to supply space cooling as well. There are few options to get gas from waste, for example, a biogas plant or a waste-to-energy plant or on-site gasification unit. A biogas plant is an anaerobic digester. Organic waste goes through two phases of digestion process with bacteria plus methanogen produced to methane and carbon dioxide This process is usually being used in large-scale waste treatment. The smallest waste-to-energy plant I can find so far is the Green Energy Machine, or GEM. It includes an on-site gasification unit. The GEM is about the size of a large garbage dumpster, and apparently it's very noisy. Designed to be parked at the back of an office building, mall, or college campus, a GEM can turn up to 3 tons of trash per day, including paper, wood, plastic, food, and agricultural waste, into 120 kilowatts of electricity, as well as the equivalent of 240 kilowatts of heat. The garbage is broken down with downdraft gasification, which uses high heat to decompose the trash in a controlled process that produces no emissions, according to the company. Small fuel pellets are then created from the decomposed trash, with gasification used again to convert the pellets into syngas. The syngas is then used in a traditional generator. Here will be the tree generation plant. Here comes to the automated vacuum waste collection system. An estate in Wembley City, North London, has installed an automated vacuum waste system to dispose of about 8,000 residents' rubbish. Color-coded containers above ground connect with underground chutes. Residents separate their rubbish items, organic, recyclable, and non-recyclable, and drop them into corresponding containers. The waste will then be sucked through a series of pipes at 70 km/h to a central collection point, where it will be picked up twice a day. The system has been used in more than 30 centuries. My question is that if it is possible to connect the automated vacuum waste collection system to a local waste collection center, after the separation of the waste, it can be fed into on-site waste-to-energy plant in order to generate renewable gas locally for the tree generation plant. Electricity can be stored in batteries or charge electric cars in off-peak time, or stored in form of hot water. A hot water storage unit can store energy produced by wind turbines or photovoltaic cells in hot water. The hot water can be used for shower. However, the energy stored in the hot water can also be fed into the heat pump system and used for heating or cooling. So far, the research project has been concentrating on understanding current available technologies on cleaner energy production and energy efficiency. For the next phase of the project, I will concentrate on the following tasks. Propose a sketch spatial configuration plan of the new power plant buildings. Second, propose a sketch location plan for the possible location of local energy generation, solar, wind, fuel cells, electrical car charging point, batteries, and hot water storage units, and so on. Third, continue doing detailed technology research. Thank you for listening.